This is lecture 1 of Surveying 1, and I want to welcome you to this course and let you know that this is the standard format that we'll be using for the lectures, and there'll be a variable number of them that are made available to you week by week. They won't always be made available at the same time. It'll just depend on the pace of the course, the kind of material that has to be developed, and so forth. So the title of this lecture is also pretty explanatory, which is it's an introduction. Now, many of you may already have some experience with surveying, but one of the things you need to do here is factor in what I am saying into what you already know. Unfortunately, there are too many people who've been doing surveying, whether that's for 6 months or 6 years, who think they know what surveying is. And one of the things that I want to kind of get you to change is to be open-minded about a much broader understanding of what surveying is, because most of the time, what you may have from work experience is a very narrow view into the field of surveying. Many of you are probably taking this course because you hope to become licensed as a surveyor, either in Missouri or some other state. And there is, again, part of that process of becoming licensed means having to take a land surveying exam. In some states, you have to go in for an interview with the board and so forth. And again, even though in many states the licensure for land surveying has to do with doing property boundary surveys, that on these exams, and if there's an interview in the interviews, there will be a much broader understanding of surveying that they will expect you to have to be able to successfully go over that hurdle so that you can become licensed. Now, I don't want to make it a carrot and stick situation where, oh God, I got to learn all this stuff so that I can become licensed, so that I can pass the exam. As you will see through this entire course, as well as all the other courses in this series, is that as a practitioner, as a professional surveyor, you need to have a broad perspective of what surveying is to present to your clients so that you can do the best possible job and get the most possible payment for your services. There is a tendency within the field of surveying for surveyors to be very narrowly focused and to act as if they are tradespeople rather than professionals. And what that does is it cheapens their services, and it makes the value of what they provide, even though it is really important, seem as if it's the same kind of service that a carpenter or a plumber would provide. And ironically, many times the surveyor is getting paid much less than that carpenter or plumber is getting. All right, I'll get up on that soapbox from time to time, but this is a great opportunity for me in this introductory part to do a lot of that. So you're going to hear that now in large quantities, but you'll certainly hear it in bits and pieces throughout the entire term. So what is surveying? So surveying has a lot to do with measurement. In fact, most people, most lay people, if they're not thinking about property boundary surveys, or even if they are, think that that's all surveying is. Now, property boundary surveying is actually a very special aspect of land surveying that goes far beyond just measurement. But certainly in this class, a lot of what we're going to be focusing on is the idea of measurement. In fact, we will almost never speak of the land surveying or property boundary surveying principles that you must also know that come from later courses in this series. So I say that surveying is large scale as opposed to small scale. So what do I mean by small scale? Well, carpenters measure, plumbers measure, tailors measure, machinists and machine shops measure, but that's not the same as what we do with surveying, because we are making measurements of the relationships between points, lines, planes, and volumes on or near the surface of the earth. Okay, I haven't written that in this slide, but that's what it is. And so to do that, we measure distances, we measure directions, and we measure elevations. That's kind of the complete story on what surveying is. And so to do that, that means for the most part, we measure horizontal and vertical distances, we measure slope distances, and then we measure horizontal and vertical angles. Sometimes it may not seem that we're doing that when we're using some of this modern technology, but in reality it all goes back down to those kinds of things. Sometimes they're direct measurements, sometimes they're indirect measurements, and we'll talk more about that as the semester progresses. And then what's inside, meaning what kinds of surveying is there inside of that general word surveying. And so I've thrown boundaries in because for many of you taking this class, being able to do boundary surveying is a big part of why you're taking this course. But there's some very fundamental aspects about surveying that kind of go across this entire set of subtopics or sub-areas within surveying. So I have here engineering surveying, construction surveying, mine surveying, hydrographic surveying. You might want to read up and see what that's all about. Geological surveying, control surveying, GIS, LIS, what does that stand for? Geographic Information Systems or Land Information Systems, aerial photogrammetry, image analysis, forestry surveying, agricultural surveying, geodesy, which is a special branch of surveying, and topographic surveying. And this is not a complete list. You can kind of collapse some of these different types of surveys into broader areas, or you can make it more granular or more fine and break it down even more into dozens, if not hundreds, of sub-areas of surveying. You should be aware that out there in the world that sometimes there is a dim view of surveying, especially by some of our fellow professionals like the engineers. And because of that, probably starting in the 60s or 70s, groups of people started to find ways to differentiate ourselves and to elevate ourselves in the minds of our peers, and quite frankly, also in the minds of the consumers, the clients that we interact with. And so one of those terms that you should be aware of and not be ashamed if you are called that is that you are a geomatics specialist. And geo, as you probably know, is a root word from the Greek which means earth. In fact, geometry simply means measuring the earth, because a lot of the early principles of geometry had to do with techniques that these early mathematicians developed to determine the size and shape of the earth from observations that they were making. Something else that's often used is the term geospatial industry or geospatial science. In fact, some programs in some universities, instead of being called surveying programs or geomatics programs, are now called programs in geospatial science. Why? Because it seems to people like legislators who apparently are not as bright as they would like to think they are, sometimes go for these terms because they sound high-tech, advanced, modern, whatever you want to call it, whereas land surveyors sometimes have that old feel to them. Many people, when you ask them what is a surveyor, what does a surveyor do, have no idea. But when they do have an idea, it's usually, aren't they the people with the cameras who stand by the side of the road, and has kind of a weird feel. Or it's what the old guys, when they were surveying this country right after the Louisiana Purchase did, but does anybody really do that anymore? That kind of thing. So geomatics, which could just as easily be surveying. I just threw this in here, this definition. This is one of the many definitions you can find when you go start looking at textbooks and professional papers. The art and the science. This is definitely an art and science thing, but geomatics can also be referring to the technologies that are related to the management of geographically referenced information. So the key part here with this definition that you might want to take to heart is this word management, because you probably know that managers always get paid more than the flunkies. And so probably when whoever put this thing together back in the 60s or 70s decided, let's throw the word management in there because it gives us kind of a higher caliber sense of we know what's going on and we're helping people make decisions about whatever it is that's being decided on or using geographically referenced information. In fact, that's where the word geospatial means. Geospatial means geographically referenced information. So one of the things I ask people to do in this class and all my surveying classes is to internalize, so that even after you become a licensed professional, even though you might be only doing land boundary surveys, to talk about these kinds of words, that you do investigation, that you do pre-analysis, that you do measurement after you've done the pre-analysis, you do post-analysis of the information or data you collect. You're involved in data management. You generate information for your clients, and you share knowledge that might be derived from generating that information. And the reason I put a comma here rather than a period is for you to think about what other things that surveyors might do that you might want to add to your own list, because this is something you should personalize and actually have at your fingertips. So I want to just do a little humorous, or it begins anyway, with a humorous sidebar. When we talk about famous surveyors, people often, or as surveyors, we have a really bad joke we like to make when we are speaking to non-surveyor audiences. We put this up and we say, how many of you have been to this place or know about this place and so forth? And of course, we're talking about Mount Rushmore. And they say, well, there are 4 people there. Do you know that we have surveyors in that group? And so the big joke is this. The big joke is that we say, even though we don't really, we say, well, we call this picture the 3 surveyors plus the other guy. And that's because the only guy who's not a surveyor is Theodore Roosevelt. So Washington, Lincoln, and Jefferson were all surveyors at one point in their career. Were they good surveyors? I have no idea. But I know Jefferson certainly was involved. He's often called the father of the U.S. Public Land Survey system, was heavily involved in designing that system. Now, of course, he had a different motive. Country was poor, had huge debts, and they knew one of the best ways to raise money was to sell off the vast lands that they had, especially after they did the Louisiana Purchase. And of course, to do that, they had to have reasonable ways of describing the land, and that's how the U.S. Public Land Survey system got created. And these are the kinds of things, these stories are things that you as surveyors should be integrating into yourselves to have as part of what's in your bloodstream or your genes, or the figurative genes that we have. Because these are the kinds of things we need to talk about when people say, what do you do? When they go, oh, how boring, because you know that's going to happen if it hasn't already happened to you. Now, getting into a little bit more detail, which doesn't always come up when you're talking with the people on the street, so to speak, are names like this that you might want to be aware of. Again, it's part of our history. So Ellicott is a very famous surveyor. He surveyed many state boundaries, especially out east, and was involved in the surveying of Washington, D.C. So the design in Washington, D.C. was actually done by a French architect, but certainly Ellicott was involved. He participated in a lot of the discussions because he understood the topography of the Washington, D.C. area very well, and then actually was in charge of doing much of the surveying to lay out the boulevards and the other areas of Washington, D.C. Rittenhouse is someone else, again, colonial times or pre-colonial times surveyor, who is also known for being an instrument manufacturer. You might want to read about Putnam, and if you Google these names, if you do a search, you'll find out more about these people. Putnam was part of George Washington's team, and he was the one who did a lot of surveying. As you know, when you conduct war, the word civil engineer comes from the fact that they worked on civil projects as opposed to military projects. So really the first engineers that ever existed were all military engineers. And these generals always wanted military engineers along because they're the ones who designed the roads to march their armies faster than if they were going cross country, and to cross rivers, and to build forts and to scale the walls of the defenders' forts and so on and so forth, to design those machines of war. So Putnam was heavily involved with Washington when it came to mapping and surveying to be able to move armies around to attack where they needed to. But there's even people like Thoreau, who are famous for the literature that they wrote, who was also a surveyor, and you can read some of his exploits as a surveyor if you go search online for some of his books on the subject, or some of his articles at least. Benjamin Banneker was actually an associate of Ellicott's. He was actually an assistant, participated in the surveying of Washington, D.C. There's actually a stamp that was issued some time ago, but in modern times, to honor him, because he was also a mathematician and a scientist. He was also kind of very distinctive in the sense that he was one of the few African Americans, free African Americans of the time, colonial times, who participated in these kinds of activities. I put the name Everest here because that's actually the name of a person long before it was the name of the tallest mountain on earth. I think he was a military or quasi-military title, and he was Surveyor General of India, but he may have actually been in the military. And when the mountain was eventually discovered or surveyed, they named it after him by a successor of his. And then I threw this name Clark. You're not going to see this name in many books, except in kind of a description of what we sometimes refer to as a spheroid or an ellipsoid. And we'll talk about this more later on. But if you're really interested, look up Clark. This is not Arthur C. Clarke, but a different Clark. I don't remember his first name, but he was out there somewhere in the 1800s. He was a British mathematician who did some very important work for what's called a mathematical model of the Earth that actually fit the United States very well. And some of you may have heard of what we refer to sometimes as the 1927 horizontal datum. Well, it's based on a spheroid or an ellipsoid that was actually designed by Mr. Clark over here. So that's just a selection. There's many, many other surveyors, and certainly in the counties that you live in, there are county surveyors, and we have, when we get into the later courses in this series, the Surveyor General or generals who were in charge of the national surveys as well as the regional surveys, and the deputies of those Surveyor Generals. These are all names that you should know, and again, should be in your bloodstream. So the history of surveying, well, many times when they talk about the history of surveying, they often talk or start by talking about the rope stretchers in Egypt. So what happened in Egypt is that relatively dry country, but lucky to have a large freshwater source, namely the Nile, that flowed through it. And as rivers are prone to do, when they had the seasonal rains, the rains would cause the waters of the Nile to rise and have floods. The floodplains would be completely inundated. And so the rope stretchers had the job in the spring after the waters receded, using landmarks that were out of reach of the floods to go back out and demarcate all the fields. Now, back in those days, of course, there was no such thing as private property. It was all owned by the king or the pharaoh. But the pharaoh would distribute favors to other people who could then hire people or permit people to live on this land so that they would raise grain or some kind of agricultural crop. It could be an animal crop. And they would then provide tax or payment to the people who had nominal charge of the land and also to the pharaoh. But this way they were able to support themselves because they could access the water of the Nile. But to access food meant that they had to do some gainful work to get food as compensation. And the problem that these rope stretchers were solving was basically, you're farming my land, or more likely, you're harvesting my crops. They wanted to avoid that problem. And the Egyptians were very efficient. They had a very good civil service. So they were very efficient at keeping things like this under control, about taxing people, making sure people didn't cheat on their taxes or escape having to pay tax, and so on and so forth. So they were always very interested in making sure the lands were properly demarcated. And the reason I say it was more likely you're harvesting my crops, because technically people didn't own land, it was all the pharaohs anyway. But it could be people started having feelings for the land, so to speak, and saying, yeah, on my land, meaning it's actually the land that I've been given permission to occupy and farm. And as I already implied, as civilized society formed and you still had despotic rulers, meaning kind of a one-man ruler, a king or a queen or a pharaoh or whatever, these people realized that to keep the population happy, they needed to provide certain services to them in order to keep them under their thumbs. And that meant building roads, building bridges, providing human habitation, sewers, especially storm sewers. Sanitary sewers were actually a much later idea that people got. Protection from floods and so forth, all required the services of engineers and eventually surveyors. Now, these rulers were not necessarily always doing this totally as an altruistic measure for their people. They also knew that the taxes, which were usually paid in kind, so many cattle, so many pigs, so much grain, whatever it is, so many olives and so forth, couldn't be supplied into the pharaoh's granaries and other storehouses if they didn't have all this infrastructure to bring all this stuff from all over Egypt to these central locations where this stuff would be stored and presumably hoarded, because that's how the pharaoh was then able to keep his armies going and raid other people and get more land and seek more treasures and all the other stuff that goes with being a pharaoh. They're such busy people. And when they started, they had very crude tools. So I already talked about rope stretchers. So obviously rope in those days was all made out of some kind of what we refer to as a vegetable product. It would be a fiber of some kind that was used to make these ropes. So they were pretty crude, because we all know that unlike the polypropylene and things like that that we use today, that these ropes could stretch and shrink depending on humidity, leave alone whether you were working in the rain or not. And a lot of the other things they used for alignment or to determine what was vertical often had wooden components with maybe a rock tied to a string for a crude plumb bob to determine the direction of gravity and so forth. And then they became adept at working with metal. They discovered how to get metal out of crude ores, for example, and to melt them down and put them in molds, and how to beat them into shape and so forth. The people who are called blacksmiths would have been the very earliest, and so they started making artifacts. They started out very crude that eventually became all these measuring tools that have been used for centuries. And with a very, very slow process of evolution on the surveyor's measuring tools. For those of you who have already been involved in some aspect of surveying, you may know that surveyors in the 1800s and the 1700s used things called chains, which were actually chains made out of heavy wire with links that were varying in length, but the most common one near the end of the period when links were used were chains that were 0.66 inches long, because 100 of them made a chain that was 66 feet long, and so the 66-foot chain actually became a unit of measure. And they used compasses and so forth very heavily in the 19th century, the 1800s. But it's only in the last 50 years that there has been a steady progression, and you could go back and say maybe in the last 100 years when we all of a sudden started to change from compasses and chains to transits and eventually theodolites for angle measurement, and from chains to steel tapes for distance measurement. And only in the last 50 years, and maybe even the last 30 or 40 years, have we had things like, so these are disruptive devices like the electronic distance meter, global positioning system, GPS, the total station, which essentially combined the electronics of an electronics distance meter into a theodolite, which then had more electronics added to it for its angle measuring capabilities. And GPS itself wasn't static. It went through several periods of sub-evolution within it, and we have many flavors of GPS, and today many people have a very skewed idea of what GPS, or even more common today. Instead of saying GPS, it's becoming more common to say GNSS, which stands for Global Navigation Satellite System, because we have systems like GLONASS, which is Russian, and Galileo, which is European, and pretty soon Beidou from China, that will have dozens and dozens of satellites in the sky rather than just a couple dozen that we can access. Then we've had things like LiDAR, which use laser-based technologies. Somewhere in here we also introduced the rotating laser level for elevation measurement. Different kinds of scanning are now being done, and probably the newest kinds of surveying are done using unmanned airborne systems, commonly called drones, which started out doing what's called close-range aerial photogrammetry, but they've started building other sensors that can be put into these drones, such as LiDAR and what's called multispectral scanning systems, to be able to do various kinds of surveying that go far beyond boundary surveying. And this is one of the reasons why having a broad idea of what surveying is important for people going into the profession, because we don't want to be limited by just the notion that if you hang up a shingle as a surveyor, that all you do is boundary surveys. There's a lot more to it than simply that. So inside of surveying, one of the first breakdowns that we often do is to divide up between plain and geodetic, and you could say plain and fancy. But here the word plane is P-L-A-N-E, which you hopefully remember from geometry whenever you studied that. Plane surveying essentially assumes that the Earth is flat, whereas geodetic surveying, sometimes referred to as geodesy, takes the shape of the size of the Earth into account. In fact, a lot of geodesy is simply making measurements on the surface of the Earth that tells us how far apart 2 points are, how they relate to each other, taking the curved nature of the Earth into account. But back here on plane surveying, even when we do things like sewers, we actually do not assume that the Earth is flat, because things would go incredibly haywire and all the water, whether it's storm water or sewage, would not get to where it's intended to go if you assume that the Earth is flat. So even in plane surveying, surveyors actually either knowingly or unknowingly wind up making compensations or corrections for the curved nature of the Earth. Now, here's the thing about geodesy. When people were doing surveying, they pretty much ignored geodesy and left it to the geodetic surveyors. But ever since GPS came into our lives, which would be the 1980s, 1990s, and certainly by 2000 had become pretty dominant in the industry, it turns out that GPS doesn't work if the designers of GPS didn't understand geodesy and take the effects and impacts of geodesy into account. So even if we are plane surveyors, P-L-A-N-E surveyors, and we're using things like GPS, we cannot ignore certain geodetic concepts. There are too many practicing surveyors out there who are totally ignorant about this and make massive mistakes and make public statements, sometimes in court, which are all wrong because they have not bothered to keep up with the times to learn about how geodesy now affects their instrumentation and therefore their measurement results. And that's why I have this here. This subject cannot be ignored. That doesn't mean that you have to become a geodesist, but you do need to understand some of the principles of geodesy to be able to practice today as a plane P-L-A-N-E surveyor. So I've already talked about different kinds of surveys. Just want to mention, so we sometimes talk about land or property boundary surveys because in all states, if you are licensed, it means that you are the only type of individual, people who have this license, who are registered as land surveyors, are the only people in the state who can perform land or property boundary surveys. For the other types of surveying, it varies from state to state. So in some states they will say, well, you can't do geodetic surveying, you can't do aerial photogrammetry, you can't do engineering surveys and so forth. You can't make topographic maps unless you're licensed. But that varies quite a bit across the states. It's pretty much a patchwork quilt in terms of what other activities within surveying are regulated. But I wanted to throw some of these out and just talk about them a little bit. So cadastral surveys have to do with measuring and inventorying the public land. And so very often a cadastral surveyor today may work for an organization like the Bureau of Land Management, which is the successor to the GLO. And I don't know if you know what the GLO is, but it stands for General Land Office. And the General Land Office was the original public lands agency that worked under the direction of the geographer of the United States to demarcate the land into section townships and ranges so that the government could sell off this land. And that work is still going on in some parts of the continental US, what sometimes we refer to as the lower 48, but certainly there's much of it that's still undone in Alaska. So this is very often government surveyors, but there are many private surveyors still doing cadastral surveys, either under contract to BLM, doing essentially working as a deputy BLM surveyor, or where they're redoing a survey that was done a long time ago. And again, we're getting into some technical topics here that talk about resurveys, dependent resurveys and independent resurveys and so forth that can happen. but that would all be called cadastral surveying activity. It has to do with inventorying land by marking it off in some regular way so that it's capable of being described easily. Then we have topographic surveying, and this is simply making maps that show the three-dimensional nature of the earth, meaning contours or some other representation like that, but also all the physical and artificial features on the surface of the earth, whether that's roads or forests or lakes or ponds and so on and so forth. Route surveying or route surveying, depending on where you come from and how you pronounce it, has to do with the surveying. It's a specialized sub-brand, if you will, or topic within engineering surveying or construction surveying, depending on what you're doing, that has to do with laying out railroads and highways and power lines and canals and so on. Things that have a long linear extent to them. And then I threw a lot of these other things in. Construction surveying. It's a surveying that's done preparatory to construction and during construction. And sometimes construction surveying also includes, you see over here, as-built surveying. Sometimes that's collapsed into construction surveying as well, because if a project is done well, it really should require an as-built survey, because seldom are projects built exactly to plan. Sometimes that's an accidental deviation, and sometimes it's an intentional deviation. But we have city surveys, which could be cadastral in nature, or they could be topographic in nature, and they could be a whole bunch of other things. Engineering surveys are sometimes pulled out as separate from construction, because we have engineering surveys that are often conducted long before construction is planned or before construction is done. So once construction starts, there is a phase of surveying that happens that sometimes is a lot more precise, so that the contractor knows exactly when they're going to hit rock or how much volume of earth they need to move in or move out or shift around and so forth. But the engineers will often create estimates based on the surveying that they've done, but sometimes that engineering that the engineers do is quite accurate, because it may be doing something like positioning a dam and where the wing walls need to be, or a massive bridge structure, or the piers for a suspension bridge, and so on and so forth. Hydrographic surveying, marine surveying, mines, forestry, geology, and so forth are all other areas. And then we have control surveying, and control surveying is similar to geodetic surveying in the sense that it's probably the most accurate form of surveying that can be done to support any of these other activities, because when you do surveying, you often need precise positions to be able to densify your surveys. And so control surveys often provide the skeleton or the framework on which all these other types of surveys would be hung, including land, cadastral, and so forth. So surveyors today use modern instruments for their data collection. As I said earlier, their prime purpose is to gather data. Now, what they do with the data varies a lot depending on whether it's a boundary survey or some of the other types of surveys we talked about. And what I say is that they must know something about the technology that they use so that they will know when it fails. Why? Because it will fail inevitably, and sometimes it fails all the time, and you need to understand the magnitude of what that failure is, and we'll talk about that in the next lecture. You also need to know things about how to maintain your surveying instrument, because it's not always brand spanking new, and how do you maintain the accuracy or level of performance that it is designed to do, because you can actually detect when it's not delivering that level of performance. And so how do you keep it in shape, so to speak? How do you transport it so it stays in that shape that it's supposed to be? So these are all parts of the professional practice of surveying that even technicians should be taught by the professionals, but is seldom done today. And that's an unfortunate part it's these lacks are some of the things that cause people to think of surveyors as being less than professional. I want to talk a little bit about the importance of surveying. Surveying impacts everyone. Let me give you an example of what I mean by that. For example, when we talk about GPS, if you're a surveyor, you think about certain kinds of GPS that you might use to perform a survey. But if you look at it in the broadest sense, probably everyone on this earth today is somehow impacted by GPS. Why? Because GPS is not only a positioning system, it's a timing system. So the generators that generate 60-cycle AC current that are on a network, they might be hundreds of miles apart, all need to be synchronized so that that AC cycle they generate is synchronized with each other. You can only do that by having microsecond timing. So microsecond is millionth of a second timing, and GPS is much better than that. It's probably picosecond, which would be billionth of a second timing that you can get from GPS. So they'll often use GPS receivers today because it's a much cheaper way to keep time control. Computer networks, same thing. Communication networks, same thing. In fact, cell phone timing, cell phone bands that you speak on or send data on are actually taking your voice, splitting it up into many parts, millions of parts, and sending it together with other data. It's kept identified so that when it gets to your end, it's put back together so that you can actually make sense of it, or if it's a modem, so you can use the data that's being transmitted. To be able to do that, you need to have microsecond or better timing. So GPS impacts us all the time in all kinds of ways. Even though we may not possess a GPS receiver, it's still affecting us all the time. So, what I want to say about the importance of surveying is that it's the same way. Why? Well, let's start with boundary surveying. The way wealth was created in this country initially, it's a little different with the dot-com world, but the way surveying was used was to help people actually create wealth, because until you owned land, you couldn't mortgage it, you couldn't sell it, you couldn't rent it, you couldn't lease it, and this was the most common way, other than agriculture, to make money. So wealth has always been related to land in this country, and most of the world this is still true, and that cannot be done unless you have proper surveying being done to go along with it, because the worst thing that can happen when you have land is to misidentify the land or to describe land in such a way that it overlaps somebody else's concept of what their land is. And this is why the boundary surveying part of it is so important. But every project you see out there that humans have built, whether they're civil engineers or not, could not have been built if surveying wasn't involved as some part of the equation, all the way from before the planning when doing reconnaissance to merely get the shape of the earth, or to determine in general, where are the mountains, where are the ridges, where are the valleys, where are the streams that we need to deal with when we build infrastructure, whether it's a small house for somebody on a lot or massive infrastructure for a municipality, a rail network, a highway network, a transmission line, and so forth. So surveying does impact everybody's lives. It's just that we as a profession have done very little to tell this story. So one of the things you need to do is think about how you express what this work is, so that when you do become a licensed professional, you can talk about how you are important to somebody else's life, rather than simply being a drain on their bank account because somebody's requiring a survey of some kind or another, and they very reluctantly hire you, and even more reluctantly part with their money for the service that you deliver. So what I say here is, don't paint yourself into a box. Yes, you may be interested in becoming licensed as a land surveyor to do property boundary surveys, but remember that there are many more slices in that loaf than just property boundary surveying that you can also eat from. And so that completes this introduction. And one of the things I want you to do is start thinking about what is surveying, what comprises the entire field of surveying, and think about some of the ways that surveying impacts people no matter who they are. Think about that a little bit, because I will be asking questions about it. And with that, we will end this lecture.